graph, quadrilateral ABCD, and we'll talk about how the heck we're going to do it a trapezoid. Make sure you have the vertices labeled as well. All right, let's talk. First, I just want to let you know some information. About 2, maybe 3 years ago, they changed the definition of trapezoid. It's actually good for us because it's less work we have to do here. Usually in the past, what we'd have to do to show a trapezoid is, all right, yep, I would need to show a pair of opposite sides parallel, but then you would need to show the other pair are not parallel. And the reason being is it could still be a parallelogram, and you wanted to eliminate that possibility. Well, 2 to 3 years ago, they said, nope, this is the only thing you need to do is show one pair of opposite sides are parallel. And what they went on from there is, hey, so a parallelogram is a trapezoid. All right, a parallelogram is a special type of trapezoid. A rectangle is a trapezoid. A rhombus is a trapezoid. A square is a trapezoid. So that is good news for us. So where it says what to do for a trapezoid, where it says if one pair of opposite sides are parallel, and you can get rid of that part right there. We do not need to show the other pair is not parallel. Could it be still a parallelogram? Yes, but that's okay because now the definition is a parallelogram is a trapezoid. All right, so we can get rid of that, which is good news for us because that's one less thing we have to do, right? All right, so how am I going to show this one's a trapezoid? One pair of opposite sides parallel. What formula am I going to need then? How do I show line sides are parallel? I'm going to need what formula? Slope formula. All right, rise over run, change in y over change in x, whatever you prefer. And it is good to graph because we don't have to waste our time. We pretty much know the two sides that are going to be parallel. So we don't even have to waste our time on AD or BC. So M for slope of AB. Me personally, I'm a rise over run guy. I don't like to do the y coordinate subtracted over the x, but if you want to do that, go ahead. Whatever floats your boat, right? So up and over, I'll ask somebody here in a second. Slope of AB for me. Slope of AB. When you have it, let me know. Boom, start us off right. Kissinger, what do you have? Slope of AB? 1/2, good. Yep, it was what, 3 over 6? But we talked last week, reduce the darn thing, all right? So you can clearly see if it's the same negative reciprocals. Good, and then the slope of DC. Slope of DC. I think you guys probably get 5 over 10, which again reduces to 1/2. And maybe this starts answering your questions now, Josh. Step 1, show the formula. Step 2, all right, what did you just learn from the formula? And you will never learn it's a trapezoid, it's a rectangle rhombus. All right, that's not what you learn. All right, I found out 2 slopes are the same. So what do I know about AB and DC then? Are they congruent? Are they perpendicular, parallel? What do I know if both slopes came out to be 1/2? Those 2 are, Gabby?
Oh, parallel. My bad.
You good?
Yeah.
Yeah, it is your bad. They are parallel. AB, even the great ones make mistakes, Gabby. Trust me, I know. AB parallel to DC, and then you're going to tell me a little because. How do we know they're parallel? And you did the work for it. Just tell me in words now. Aiden?
Because the slopes are equal.
Done. Because slopes are equal. And then now we're good. Usually I'd have to tell you the other pair are not parallel, but we don't have to do that anymore. One pair of opposite sides parallel, good enough to say ABCD is a trapezoid. Because you guys take over from here now in your own words. You let me know. How do I know this bad boy's a trapezoid? Let's roll here. Ian, how do you know?
Because the opposite sides are parallel, one pair.
Thank you. Got to have the one pair, right? Because if I say opposite sides are parallel, I didn't show that. Because one pair of opposite sides parallel. There it is. That's a trapezoid. Any questions? That's a nice one, huh? Just have to show one pair. Now, the only other thing I could ask you is now, how do you show me it's isosceles? An isosceles trapezoid. Same thing, except we have one extra step. So go ahead and graph. Go ahead and graph here. Same thing, except now just one extra step. All right, ready to roll. Okay, so it's an isosceles trapezoid. All right, so now, yes, I still need to show one pair of opposite sides parallel, but now the non-parallel sides you do need to show are congruent, the legs. So that's what I need to show right now. So this is the first time I think we're going to need both formulas. All right, let's first start with the parallel part. I'm going to need slopes, and hopefully this is an easy one for you. You don't even have to do rise over run for this. Any horizontal line, what do you got for me? Slope of? AR is horizontal, NO is horizontal, so slope of? Oh boy. Huh? Is it or undefined? Which one is it? 50-50. Zero, yes, vertical lines are undefined. Slope of 0, same thing with NO. That also has a slope of 0, done. And then again, just like we've been doing, right? Stay consistent and neat and organized. Step 2, what did we just learn? AR, put something in between those bad boys for me. AR and NO. Let's go. Zeev, they are parallel. Why? Done. Hello, Matt.
If you put congruent, would that be wrong? Slopes are congruent.
Yeah, I'm fine with that. I'm not going to fight that. If you put AR and NO congruent, then yeah, I do have an issue with that, but no, not at all. All right, step 3 now. We know those are parallel. Now we have to show the legs are congruent. So what formula am I going to need now? Distance formula. All right, so this is the first coordinate proof, I think, anyway, unless you've done your different methods, but the first coordinate proof we've done together where we've used both formulas. All right, so let's go on AN. I'll go AN first. Again, somebody said, hey, can I use Pythagorean theorem? Sure. It's the distance formula. Do I have to write it? Oh, I'm not writing it out, right? Change in your x's minus the change in your y's. Or if you show my little, I hate calling it a cheat code because it is math, but 3 is the difference in your y's and 4 is the difference in your x's. So it's going to be 3 squared and 4 squared. That's what you would get out if you subtracted in your parentheses. Make sure you add everything first or just plug it in your calculator because it'll do a lot of work for you. And then you end up with 5. And again, I know we got some slicksters in here, some very clever students. You still have to, I know it's going to be 5 for RO, but you got to show me what you plugged in to get 5. All right, just don't write RO equals 5. Got to see what you plugged in to get 5. And then step 4, what did we just learn about those two? What did we just learn there? Ian, what did you just learn?
Distances are congruent.
So that means what about AN and RO? There you go. AN congruent to RO because distances are equal. I don't know if anybody is thinking this, but you would be correct. Hey, Mr. Carlino, can I just put step 3 in with step 1 and just show the distances and slopes all in one and then put my reasoning for step 4 in with step 2? Yeah, that's fine. Again, I'm just looking for organization and it's neat. Okay, if you want to put all of this 4 steps into 2, completely all right. Make sure it's neat and organized. And then the final step, no matter how many you have total, is hey, Nora, N-O-R-A. Oh yeah, that did spell Nora. I didn't see that. Nora is an isosceles trapezoid because, who's going to have this finisher here? Oh boy, this is going to be a mouthful. In your own words, how do we know Nora is an isosceles trapezoid? In your own words. When you're ready, go ahead, Gianna, when you're ready.
Because one pair of opposite sides are parallel and one pair of opposite sides are congruent.
Yes, I would just like to say the other pair is congruent. Okay, is the other pair is so because one pair of opposite sides congruent, and you can say non-parallel sides. You can say the legs, whatever you want to refer to them as. All right, and non-parallel sides are parallel. Or hold on. One pair of opposite sides are parallel. Let me get my wording straight. And the non-parallel are congruent. Or again, I could substitute in the word legs here if you want. Okay. All right, everyone, all right. Coordinate proof for either a trapezoid or isosceles trapezoid. Last thing I want to do today is show you a special segment that is in every trapezoid. A special segment that is in all the trapezoids. First thing I need you and your group to do is I need you to do me a favor. Can you take the midpoint of RO and the midpoint of AN and call them E and F? Find those midpoints for me, please. What are the coordinates of those midpoints? So you're going to take the midpoint of RO using the midpoint formula, call it E, and then you're going to, is it RO first or do I have that right? Yep, OR. And then you're going to find the midpoint of AN and call it F. So that's what I'd like you and your group to do first is find those midpoints. And I don't think on December 18th, I should be giving you the midpoint formula again. I think you guys have that down pat. So go ahead, find the midpoints for me, and then we'll move on. Take a look around quick, discuss it. Did we get the same midpoints?
Oh, that's plus.
Hey, how about those midpoints? Can I get point E, the midpoint of RO? The midpoint of RO, please. There we go. Charlie, midpoint of RO.
5. 4.5.
5, and what was the other one? 4.5. Good. I like that. And how about F, the midpoint of AN for me? F, the midpoint of AN. Ian, back to you.
-1, 4.5.
Good. Everyone throw that on the graph as best as possible, please. And I'd like you to connect it, please. Connect E and F. So it forms a line segment EF. What you have just created is a special segment in any trapezoid. When you connect the sides, when you connect the midpoints of the non-parallel sides, you have what's called, and I'll get back to this page in a second, you have what's called a mid-segment. Okay, this is called a mid-segment, what you guys just drew in for me. That is when you connect the midpoints of the non-parallel sides. Mid-segment. I'd like you to figure out two properties of a mid-segment for me. So let's go back to my questions. Can you quickly find what the slope of EF is? What's the slope of EF here? Should go pretty quick, right? Slope of EF. Oh boy! Aiden?
0.
Darn right, it's a horizontal line. So here's property number 1 we're going to write down. Wait a second. It came out to be 0. Remember our coordinate proof we did? So were the bases. They also came out to be 0. So what can I say about all three if all three of their slopes came out to be the same? The bases and the mid-segment are all what? If the slopes came out to be the same. One zip, Matt. They're all parallel. So everyone, here you go. Here's property number 1. Properties of a mid-segment. It is parallel to the bases. It is parallel to the bases. We just proved that because they all have the same slopes. Property number 2, let's go back now. You guys can help me find property number 2, the last question, part D. Please find the length of all three of those now, the bases and the mid-segment. So find the length of AR, find the length of EF, and find the length of NO. And hopefully you don't need to use distance formula if you know how to count. All right, I do not need a distance formula here. AR, how long? That's what I thought. 2. Mid-segment EF? 6. And how about base NO? 10. All right, so I need your help now. Knowing the two base lengths, how can you find the mid-segment length? If I give you the two lengths of the bases, how can you calculate the mid-segment length? I know one example isn't too much, but take a look. One base came out to be 10, the other came out to be 10, and the mid-segment was 6. So now, look, for instance, if I give you one base is 14, base 1, base 2 comes out to be 12. Or actually, that's probably, how about 20? How can you find me what the mid-segment is now? Right, that's what I'm looking for. How can you find, given the two base lengths, what the mid-segment's going to be? Gianna, go ahead.
Equal distance from the two numbers.
And just not distance between, like here, the distance is what, 8? But it came out to be 6. So you're doing the average, right? Yes, exactly. You add them up, you add the two bases and divide by 2, correct? All right, so here's the property in mathematical terms. The length of any midsegment is equal to half the sum of the bases. Okay? Half the length of any midsegment is equal to half the sum of the bases. And a midsegment connects the midpoints of the non-parallel sides. So I'd like you and your group to take these two properties and look at this isosceles trapezoid below and figure out the values of x and y. All right, so use those two properties. I'm telling, hey, be careful here. It's isosceles and this is a midsegment. All right, don't overlook the part that's an isosceles trapezoid and you got a couple properties that you could use. All right, so go ahead. You and your group discuss how, using these two new properties of a midsegment, how can I find x and y? And it's an isosceles trapezoid.
Yeah, what you guys get for that?
All right, ready to roll? Talk a little bit. I tried to stress to you guys before I let you go, hey, this is isosceles trapezoid because I want you to remember the properties, one of them being the base angles are congruent. So if that was 72, that one's 72. And also remembering that everything is parallel to each other. So whether you take the two bases and notice these two are same side interior, or maybe some of you said, hey, the mid segment and a base are parallel. So if that's 72, the corresponding angle here is 72. And what do I still have though? It doesn't matter what I take, 5y minus 2, and no matter where I put the 72 are same side interior angles. And are they congruent or supplementary? Supplementary, so I'm hoping people didn't set them equal. Okay, those are same side interior angles. So 5y minus 2 plus 72 equals a buck 80. They're not equal to each other. They are supplementary. So that gives me 5y equals 110. Y is equal to 2, carry the 1, 22. So we're okay there. Any questions? And finally, the length of this mid segment, 2x minus 5, is equal to half the sum of the bases, 32 and 13. Every mid segment is equal to half the sum of their bases. So 2x minus 5 equals, oh, I screwed this up last class, a half of 45. Let's see if I can redeem myself. 22 and a half. Haven't redeemed myself yet. 2x equals 27 and a half. 13.75. There we go. Questions? This is why I always record this class. I sound like a genius because I don't make the same mistakes I've made third period. We're all good? All right, let's start it up. Let's get out of here with no homework. What do you say? Tomorrow we're just going to go over some more coordinate proofs.